Welcome to another GCBASIC tutorial. This set of tutorial is for the PIC18FxxQ35 chip family, and this is really part one. This is doing the basics. We're going to turn some LEDs on, but we're going to do the setup as well. So welcome to a new set of tutorials for this relatively new chip that now GCBASIC supports. So part one, turn on an LED. So like and subscribe the videos, please. Subscribe to the channel. It all helps the metrics. So what is this PIC18FxxQ35? It's a high performance PIC18, relatively new, been supported by GCBASIC for about 8 months, but now I've done the demonstrations that really verify and test it throughout. What it's got, these features here in bold: digital and analog peripherals, ADCs, lots of communication interfaces, pulse width modulation, CLCs, and integrated op-amps. And it comes in different parts: a 28-pin part, 40, and a 44. Now, what is important, I'm going to be using a 40-pin. That's because the one that's Micro's chip sent to me. Okay, well, they sent me a series of them, and so these tutorials apply to all of the the Q35 series. However, the demonstrations, you'll find the same for all the 18F chips. So what we're going to do is install the hardware and make this board work. So what is GCBASIC? It's an open source compiler for PICs and AVR microcontrollers. And as I said, it now supports the 18FxxQ35 chip family. No key messages in there. We'll peel back the compiler as we go through the tutorials. So the basic setup to flash these LEDs, you go and download some software. Now here's a URL. I'll put this in the comments. This URL will show you how to install. I'm assuming that you've done that. I'm assuming you've installed some programmer software. If you need to know how to do that, relatively simple, many different options. I'll show you what I'm using. And I'm assuming that you've tested that the 18FxxQ35 is attached to your system. And I'll show you that very shortly. Well, no, we can do that now. Why don't we do that now? So I'm just going to clear the screen down. I am just going to open up my task manager. I'm in Windows, and I'm just going to select PIC2 Plus. That is my chosen software to talk to this particular chip. I'll zoom in on that for you. Why do I choose this? I maintain and sell it. Okay, it's very good. And this is essentially told me up here in the device, it has found attached a 46Q35, 18F4635. It's got a particular set of numbers behind it, and I can do some clever stuff. I can like erase the chip, and you might go, oh, what's it? How do I know it's attached? Well, it wouldn't be doing that if it wasn't attached. Okay, so if I sort of come into here and I put something in the memory, in both the program memory and the EEPROM, I write that out. It's talking to my Q35 that's attached. What it's attached to, I'll peel back in a moment for you. So we go back to my desktop. We'll look at where we are. So this is the hardware I'm actually using. I'm using a prototype board. It's actually from 2010. Slightly different one, but it's very similar to this. It's got some great features. Because it gives me, I can apply power to it. I can attach my program with these. I've got my LEDs and resistors already set up. So I'll show you mine. This is mine. This is the actual one here. I've got a 46Q35 sitting here. It's got GCBASIC, so you can see it. Look, it's LEDs. Sorry, LCD LEDs. EEPROM sensors, serial, sound. Ooh, it's got a real-time clock. It's got so much stuff. And this is the major features it's got. It takes 18, 28, 40-pin sockets, and you can put that in there. And these are available on eBay. I bought this one on eBay, 15 British pounds. It's got regulators, RS232. You've got your easy program to the PIC kits. You've got I2C, SPIs, power indicators. It just goes on and on and on. And we're going to use an awful lot of this actually in the tutorials. And there is another tutorial that shows you how to use this board exclusively. So let me have a look at what's in my. So what we're going to do is what's really good about this board. It's fully documented, and you'll find all that documentation in the support folder, which I'll show you. And we're going to talk to some LEDs, which are at the top right-hand corner there in that red box. If I zoom in on that, we'll see what it is. So essentially what I've got is 4 LEDs on a port RB0, RB1, RB2, RB3, and they go through some suitable resistors to the LEDs and down to ground. So if I bring these ports high, the LEDs should come on and off. Where are the LEDs? Let's have a quick look at the camera. LEDs are here at the top, underneath that little microphone thing that says it's turned on, which I shall now mute. I guess I should mute it. There we go. It's up here at the top, top middle, and we'll see those come on. So what we're going to do is we're going to look at three example pieces of code to make the LEDs work. So where can I find these? You're going to find these in this folder: demos, vendor board, microchip demo, PICDEM 2 plus board 2010 18F. So let me just get that up for you. And in here, I'll zoom in on that so you can just see it. Look, there are all the demonstrations all laid out for you, plus all the tutorials will be in here. Plus, in this folder here, there is a set of resources, which is all the bill of materials for this particular board. So try and give you everything that you need. Back to what we're going to be doing. Hello world, blink the LED and blink the LEDs. So we're going to just go through a couple of things and see how it all works. So let's go straight into it. We've seen that I can talk to the PIC kits, the PIC itself. Let me show you something that's coming to mind, which is the board. So I've got attached to it a programmer. I could have attached one of these. I could have attached one of these, which is the one that I sell. I could have attached one of these, which is PICKit4 or PICKit5. I could have attached one of these. Look, they all work with the Q35. The basic operations, put a program in there are quite simple. Now, we're going to talk about this board as we go forward. So let's have a look at what we've got. Back to my desktop. So let's just blank the PowerPoint for a moment. Great. Press the Windows and open up a GC Studio. That's what I've installed. That's what the IDE is called, GC Studio. And it comes up with the banner. It might do an update depending where you are. And it comes up with a screen that looks like this. And I've got open recent, and so I don't have to hunt around. It's actually, I've been in there before, so I can simply open up the demonstration folder, and in here we'll just have a quick look. I can open a file, single file. I can open a folder, local folder, which is what effectively I will be doing, or create a new project. And all of these have different capabilities. Whilst we're in here, if you want to install the information pack or these demos, at the bottom to the right of the about is the how to go and get all these demonstrations. They're not normally installed. Okay, I am running the latest version of this software, so I've got a different thing, little package manager. You'll have the same thing for later on. And this is the configuration up here, a little spanner. You can click on that and it will tell you some things, and we'll look at that later on. I'll press back. So I'm going to open up my local folder, and it will put it in my recent. So my local, here's the folder, vendor boards, microchip PICDEM 2 plus board 2010 18F. I select that folder and it opens up the IDE. It might open up this bottom window depending what you've got. This is called a terminal. I'll just close that by pressing the close key. Okay, let's just look at what we've got here. On the left, we've got some icons. Let's rip through these. File Explorer, all the demonstrations. Click it. I can search for something. I've got source control. I can do a run and debug, which is one of the capabilities. There's a couple of videos on that, and extensions that have been installed in this IDE. So if I want to open a file, I simply open the Explorer. I can click on it, or I can press Control B. I will tell you what I'm doing and hello world. Let me Control B that to get rid of it. Don't really need that out there anymore. Oh, I tell you what we do. We'll load all three up. Click, 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 click. And now they're all loaded that we're going to be looking at. Control B to get rid of that. And hello world. This is essentially, this is a program. There's a header. Anything in green is a header. I'll come back to this VDIO is critical for operation later on. We'll look at that in some detail. So anything in green is comments. Hash chip 18FxxQ35 needs to match the chip. Now that in itself will tell the compiler to do a lot of configuration for you automatically. The minimum program is that one line. It won't do very much, but it would program. But if I click on hash, put the word, and then we just click on that all the way across, press function key F1, it brings up the help. If I type in here, hash chip, it would give you exactly what hash chip does. And it says, specify the model with a frequency. You don't need the frequency because it will actually always default to the maximum frequency of the chip specified. Option explicit, moving on, is you need to declare your variables. And then I've given you a little layout of the ports that we're using. And as I said before, we're using ports 0 to 3. This is the whole program. I am saying set the direction, dir, it will set a port to input as an in or an out, set a specific port as an output, set all four, and then set them to a value of 1, which means turn them on. End. Well, magic will happen. We can generate a program, and there's a menu, some icons at the top right-hand corner. I can press H there, and it will then compile that program. Hello world, and it's compiled it. Tells us it's 11 lines long. It's used 0.14% of the chip, no RAM, and it's going to work at 64 megahertz. So how do I program it? Easy way is there's a little option menu up here, but I use function key F4 and type in prefs, edit preferences. And in here, I will zoom in for you. It's what's called the preferences tool. And in the preferences tool, I've got 3 tabs. I've got programmers, compiler options, and tool variables. Today, we're just going to look at programmers. And essentially, you've got, I'll take that out. I will just put it there for the time being. And if I just do that all again for you, function key F4, edit preferences, it will bring it back up. There's my desktop. Now, why has that opened up? Oh, there we go. 3 sections. Programmers to use is empty. There's nothing underneath it. Other programmers available, and then define programmers but not installed. So these are 3 different sections. I want to use one that says PICKit plus command auto on and off. And I'm going to drop it under there, and I've installed a programmer. There are many different programmers. I showed you a few of them. If you want to use PICKit 4, PICKit 5, you can use PICKit plus, Northern Software is in here. Look, there's so many of them, okay? Press add, and I'm going to press OK. You can't quite see that on the screen. I'll just reset the size so that you can see me press OK. OK, and it's now saved that change. Back to my desktop. Now, if I press the top right-hand icon here, make hexam flash, which is or function key F5, they do the same thing. It will compile, download the program. It's erasing the part, and it's done it. What's it done? It should have set the LEDs on. We have 4 LEDs on here. Let me just reprogram that. I'll keep the camera where it is. Function key F5 just to reprogram it. You can't see it. I'm doing it off screen. If you're wondering why RB0 is actually has some light on it, it's the way that this board is designed. 4 LEDs. So we have programmed this via one of these, which is just a simple programmer. As I said, it could be any of the suite. And we've made this chip work. So we have the basic operations working. Back to my desktop. Why don't we look at number 2 then? So what's different about number 2 is we specify the chip, option explicit. In the program, you press Control J or close this bottom window, get out of the way. We're just going to set the whole port as an output. DIR, direct, direction, port, B out. And what I'm going to do is a do loop. I've got concepts of loop slot in here. Do loop, do it forever. I'm going to set the port to 255. That's turn the whole port on effectively. Wait 500 milliseconds and then turn them off by setting it to 0. Function key F5 to program that. I wonder if I can see. Oh, there we go. Look at that. We can see the LEDs flashing here, and we can see that the program has done its funky stuff. So let me go back to this command here. I'm going to change the frequency. I'm going to put in 1 megahertz. Oh, that won't work because it's a typo. What's important here is that the compiler is recalculating the delay cycles in the wait statement for you. Does that automatically, so you don't have to do it. You know, one of the benefits of that is it will always flash every 500 milliseconds. And if I put in 31K, it will do the same. So I can control the frequency of my chip just by adding that in there. We'll generally leave it at 64 megahertz by not specifying anything. There we go. Pick it up. And you can't, obviously there's less power being used for each option. And there we go. What's about number 3? Demo 3. So if I look in there, what have we got? Same header here, chip and option explicit. And now I'm introducing the concept of constants. So in the constants, constant is something that is not changeable within the program. I'm saying hash define LED 0. LED 0 here is on port 0. LED 1 is on B.1, LED 2, B2, etc. Then I'm saying set the LEDs to an output. So I'm using this reference here, and GCBASIC, as with other languages, it will actually replace any reference for that constant LED D0 with its address. And then here we got a do loop. And I'm saying in here, wait for 100 milliseconds. You could say one second. It's the same. All that is documented. So if I press highlight it, press function key F1, it takes me to the wait command. So you can look at the units there. It's microseconds through to hours. And now I'm saying here, LED 1, which equates to port B.1, is not the LED. So basically, it's going to toggle it. I'm going to program that by pushing this icon at the top. reprogramming it as I was speaking, and now we've got LED 1, which is here, RB1 flashing. The beauty of using a constant is if I change the code in here, I don't have to, I can just change it in one place. So I can just reprogram things really easy. I don't have to remember what that port address was. And now it will reprogram it and put it on the other LED. So what we're seeing here is the basic operations of the compiler doing its stuff inside the controller here. What's happening inside of the compiler is just as interesting, because it's called GCBASIC, but it's actually written generating assembly. And inside of the development folder, you have got all the files that you can have a look through. I'll show you some of those. Blink another way is selected. If I press function key F4, I can say open assembly ASM, open ASM, and it will show me the assembly that was just been generated for this program. And it will give you the version of the compiler. I'm using build 1615. It will tell you lots of stuff in here. It will tell you what the configuration has been automatically set to. It will tell you the variables. And here is the actual assembly with all the debug in there for you to have a look at. But what else can you have a look at? If you select the file, right-hand mouse button, reveal in File Explorer, it will take you into here. Now, you've got what's called the CDF file, and these are all the constants, and it's quite a lot. You can have a look at that. There's the hex file. There is blink another way. .html. I'll bring that into screen here. It's a compilation report. It says here that's the version 1615. That's how long it took. This is the resources, and then down here it will tell you what subroutines have been used and their compiled size and what calls they're making out, and also the variable map, what variables have been defined by the program. Also in there, you've got one thing called the HXL file, which actually gives you a map of how the chip was used, it's been utilized. And it says in here that from address 000, there's a bit of code, then there's a little break, there's a load of assembly, and then there's a configuration at the bottom end. This is similar to the microchip file, but tell you what, it's a bit better because it's got a lot more information, and it does it for AVRs as well. So what we've got are many files that are generated by this. So how do you get rid of them all? Function key F4, type in the word clean, and it will clean up. And everything in here has been deleted, cleared out, but you can recreate it with ease. There we go. So we've seen quite a lot. We've seen where the demonstrations are. Basic operations of an LED. We blink the LED, and we blink the LEDs using constants and 2 commands. Pretty simple. The installation is easy. Getting the software is easy. And next time, what we'll do is we're going to make those 4 LEDs flash in sequence. But quite cool. So we've proved quite a lot already. Enjoy.